Hi again, another short video to take you through how to find the standard deviation for ungrouped data. And so the standard, we looked at the mean, which tells you the center point of the data set, the value around which all the other values center. Now, the standard deviation tells you the level of dispersion or the level of variation in that data set. So, small standard deviation means the values are not very varied, whereas a big standard deviation would tell you that the values are pretty much widely spread out around the mean. And so you have your standard formulas, which really looks at subtracting each value from the mean. You square what you get, you add it up, and you divide it by the number of values in the distribution. But we prefer to use the shortcut formulas. And so there are two expressions that this formula requires. The first is the sum of x squared, which means that we square all the individual values and we add up what we get. And then it's the sum of x, and we square that, divide it by n, and then we divide everything. We minus the top and divide everything by n. Where you have population values, your measure is sigma squared. This is the variance. Where you have sample values, your measure is s squared. This is the variance for sample data. And you find that the denominator for the formula is the degrees of freedom, which is n minus 1. So this is a key difference. So you have to first determine whether you're working with population data or sample data, so you know which of the formula to apply. And so the standard deviation is the square root of the variance. So for population, it would be sigma. For sample, it would be s. And so that's the first thing to determine. Now, if we look at an example of a data set, so we have 10 typists applying for a job at a trust company, and they made the following scores on a typing speed test. And so we have each applicant and the score that they recorded. So for each of the scores, this would be the individual x values. And so to use this in our formula now, what it would require, it's easy if we lay it out in a table format. So we list all the 10 values. We know that our formula requires us to find two things. One is the sum of x, and two is the sum of x squared. So to find the sum of x, we add up each of these individual x values, and you can check this back in your calculator. If you add these 10 values, you should get a value of 729. Now, the formula also requires the sum of x squared, which requires us to square each of these individual x values. So it's 54 squared, 55 squared, 79 squared, and so on. We square each of these individual x values and we add them up, and that gives you the sum of x squared, which we can see for this example is 54,393. Now, once we have that, then we have to work the formula. So the formula requires the sum of x squared, which is always going to be the bigger value. So this goes first. And then the sum of x, the smaller value, we have to square that and divide it by the number of values we have. This is a sample data set, so it's going to be n minus 1, so 10 minus 1. So when you square this value, you're going to get a very big value. So what you want to do is divide it first before you minus. So you divide this by 10, because 10 is a sample size in this case, divide it by 10. And when you divide that by 10, so in this case we get 531,441. We divide that by 10, we get 53,144.1. So now we can minus that from our 54,393. That gives us 1,248.9. We divide that by 9. And we get our variance. We take the square root of the variance, and that gives us the standard deviation. So the thing with this formula is that you can never get a negative outcome. And so to ensure that, make sure that you put the bigger value, which is the sum of x squared. This goes first. The sum of x, you want to square that and divide it by n before you minus from this value. And so you square 729, you get this big value. You divide that by 10, you get this smaller value. Then you minus that from the sum of x squared. And then you divide by n minus 1, which in this case is 9. Once you get that value, you then take the square root of it, and that gives you your standard deviation.